Hi, I'm Shane McGrath. Today I'm going to talk about a paper about recommendation systems called All Roads Lead to Rome. Paper that was released this year, and it was Chinese as well. The Chinese have, with their e-commerce companies, have made recommendation systems as a the recommendation system community, let's just say, is a vibrant one in China. Um, just a bit of background about me. I've over 10 years experience in the data analytics space and degrees in economics, maths, and statistics. Cool. So I'll just share uh, the keynote here. Yeah, so yeah, the intro, all roads lead to Rome. The researchers are essentially this paper was the best kind of survey I'd seen about LLMs and their influence, let's just say, on recommendation systems and how they might influence recommendation systems going forward. Yeah, so the kind of the change with LLMs, I suppose, is due to their scale and inherent knowledge. They can uh, provide data for recommendation systems in ways that machine learning systems wouldn't have been able to uh, have as much context before, just because a lot of AI models would be very task specific. I think I read a quote somewhere about Amazon saying that they didn't do cross category kind of recommendations, because they didn't think that it influenced the people that people's preferences in music mightn't influence their preferences in cookery or something like that. However, another reason for this is that a lot of these sort of recommendation algorithms would be quite category specific. I know that like there's been analytics, um, large scale analytics projects such as kind of club cards and that sort of stuff. Those sort of analytics projects, but it said recommend LLMs kind of are a step forward in that direction of recommendation systems being able to have more context and be less tied to their their kind of current categories. Um, Particularly the agents that recommendation systems can or that LLMs have been where the LLM space has been developing towards. Cool. So yeah, this is this is a chart which shows the trajectory of modern recommendation systems. The researchers kind of say that there's two essential directions of optimizing recommendation systems. It is improving effective information by making more accurate and helpful recommendations. And then the second is the decreasing user interaction caused by freeing users from frequent and time-consuming operations. So kind of in this way, I mentioned before that uh, transformers are kind of like signal processors. So this is, I don't know, my feeling. This is signal processing really. So the LM or the recommendation system is looking for signals. I've read that before about recommendation systems. However, it kind of goes does uh, kind of not or kind of join up this sort of idea of the LLM being a signal processor and the reasoning capabilities being kind of signal processing essentially. Um, deep learning and list, so that's the kind of the way of the present. Deep learning and list. So this is kind of your your algorithms on YouTube or Spotify. They're list based. They're kind of very split into different tasks based off. the ability of the computing system to be able to process data essentially. However, this doesn't allow for like noisy signals and um, context, category kind of context. The kind of siloed, I suppose, is the word. So then you kind of move towards LLM agents, where you might have these sort of list-based specialist algorithms being kind of feature enhanced and data enhanced with LLMs, where the kind of LLM's ability to use text as a way to um, kind of cross categorize or cross contextualize data allows the LLM to uh, improve the training data and improve the features in particular of a recommendation uh, algorithm. And then you go up to, so these are the ones of where it's more focused on improving the effective information. So this is the information available to the AI or the machine learning uh, to um, to to approximate the preferences, I suppose, of the end user. Yeah, and then so above those ones are um, conversation, and then so these ones have the interaction where the interaction cost the is lower. However, the ability to collect more effective information through conversational AI. So this is kind of, as I said, the dilemma of being able to capture the information but reduce the amount of time that's needed to capture the information. So they talk about older kind of chatbots and then LLM kind of chatbots, conversational search. I think, like I said, these sorts of uh, algorithms are or kind of features are present in I think modern day kind of websites. And then the the kind of conversation chatbots and the kind of list-based deep learning LLMs, they will kind of converge at these kind of agents. So these are kind of information kind of seeking agents that are kind of trained or have some of the data of the end user, and you know they kind of present almost like a combination of the conversational AI and the kind of list-based browsing experiences. These kind of agents present and also seek the information on behalf of the user. So crucially, they're more information seeking than the conversational AI and the list-based AI. Yeah, so they define the recommendation agent as an advanced information seeking system that is capable of perceiving its environment, um, users, including context. So, crucially, this is the kind of software agent idea of um, being able to perceive the environment, and LLMs can add more kind of context to this with their more range of data or of context or approximation capabilities from uh, different fields, I suppose, um, and autonomously planning. So this is again some of the agent kind of capabilities, such as autonomously planning information seeking tasks, such as identifying user intentions. Some of this information would have to be built up over time, decomposing tasks. This is again towards the planning, a reflection. So this is the ability to make plans, retrieving memory. So this again is the interaction history. This is a feature of things like vector databases invoking tool use. Again, this is kind of where LLMs are moving towards, as opposed to the idea of LLMs being like search engines. Um, in the previous form where ChatGPT was kind of seen as a search engine. Now OpenAI are actually they made a search engine because well ChatGPT is a great chatbot and it can provide a lot of information. There's other information that it just doesn't have to, and you'd have to keep training it, all that sort of stuff. Essentially, an approximation kind of engine of sorts, and then taking actions such as providing rankings of lists, so this is the recommendation, giving replies, and clarifying questions, with effectively satisfying user needs with minimal user effort. So yeah, it's a the LM agents at the moment are kind of have some of these features, don't have other parts of the features. Hallucinations, again, are a key feature, even though they are being kind of lessened or decreased. Again, kind of prevent some of the autonomous capabilities that these agents might have. This is a graph of the agent. So the agent is the LM, kind of like the agent's the center there, and then you have like the orbit around it of the action and the kind of the use of the wrench or the pencil, and then the memory, planning, perception, and then the API. So this is the ability of the LM to access APIs depending on it's a standardized um, uh, API protocols and things like that. And then, yeah, collaboration with other agents. Because I said, um, any sort of multi-agent system has specialized agents that have different capabilities. Crucially, a software agent is we call a software a wrapper, but this is just a kind of contained piece of software that has certain capabilities. And the main difference between LMs or AI kind of software is just their ability to make inferences, means that they can do stuff that they haven't necessarily been programmed for. I remember watching a podcast by this guy called Francois Chalet, and he kind of compared it as a prism or a kind of kaleidoscope, where using kind of primitives of functions, the agent can kind of recombine them in ways that hadn't been necessarily programmed, or even kind of the training data mightn't necessarily have been set up in that way. Yeah, so these things would be kind of called reasoning or tacit composition or reflection. It's essentially just um, yeah, program composition based off the training data and primitives, I think are the term used. So yeah, and then profiles, interactions, and then conversations. Cool. So what's next? So the paper kind of goes through the trends and then presents the agent as the kind of the next stage. Yeah, so browsing to experience, you got to go from browsing a website to kind of a tailored kind of experience for the end user, based off their interaction history. Um, Context aware, crucially, so it might have data from other data sources that it's able to easily incorporate into a kind of browsing experience. Like I've kind of looked at a bit of it, kind of generative UI and how LMs can um, kind of present information dynamically, that previously task automation that uh, previously would have had to be um, would be very difficult to do with either supervised learning, reinforcement learning, or intent kind of reviewing. So the LMs kind of present a way for kind of UI and graphics designers to automate parts of their or kind of present kind of new kind of interfaces that hadn't been that were not possible before, specifically um, optimized around the end user and their interactions, or I suppose preferences. It's a situationally aware context, and so you're kind of moving away from the kind of chatbot to the kind of interaction interface, where the LM using, I suppose, kind of um, something like um, kind of text, some sort of I think I said I kind of see it before. Or no, I'd research it as like uh, not field context languages, but that sort of thing. Um, yeah, so from recommend virtual to reality recommender. So this is kind of the adaptive systems where you can kind of take uh, the online version of a that a agent might have learned about a end user, and then this can be kind of fed into kind of a offline setting or more embodied setting. So the embodied agent can kind of have a an idea of how to adapt to the end user based off some of their online kind of interactions. So you kind of have a world where the online interactions are a basis of the offline interaction. So the online avatar, let's just say, becomes a mirror in a way of the personality, or not even personality, but preferences or preferences of the end user. And this again could be a way for things such as how personalized robotics, or those sorts of areas where the user is not just interacting with a kind of program, but the interactions from that program can be used as a basis for interactions with other systems that may be embodied. Um, as I said, crucially, it allows for the personalized interactions. Cool. From tool to assistant. So this said you kind of go away from the search engine to the recommendation system. I remember previously reading about how recommendation systems and search engines are kind of the same basic information kind of uh, structure is needed for either. So they're very similar. So I said in this personalized embodied world of for instance, personalized robotics or something like that. Um, because the embodied agent in this case has a profile of the end user kind of constructed, then they can be more proactive. If you could say than previously without this sort of recommendation system backbone, if without these sort of agents that have these kind of profiles of the end user. Uh, from perception to cognition. So it's not so much about signal processing; it's more about kind of signal processing and understanding. So the signal processing is kind of reaches more a more grander scale. So the systems go beyond the kind of surface level behavior and then infer more abstract intentions. So this is again, you can kind of see this with the LMs, where you can kind of go from one category to another category through context of like even into like unified embeddings. Um, so yeah, I said the research may also integrate cognitive science uh, in this way. So they said from the tool to the assistant, then the agent is you're not only interacting with it in perhaps in an embodied way, but it's also seeking information for you about things that you may like or want. Um, and again, this could be perhaps tied to a production system where you might have like a budget, let's just say, and the agent is able to use that as a constraint to dynamically update perhaps like a weekly shopping list or something like that. And then that could also be tied to similar sorts of agents that would um, uh, do, do this on for the commercial end. Um, Again, kind of this is slightly hypothetical, but again, there are Chinese companies who do this sort of thing where they link manufacturers and consumers directly based off agent and recommendation systems. Um, yeah, so you go from product to ecosystem. The agent itself is part of a unified ecosystem. Now, again, there are current issues with regard to building kind of unified representation um, currently. So it's not like this is immediately present. However, you might get like a digital version of yourself that of not of yourself, but that could be used to be tailor um, um, yeah, it's a tailor other kind of companies, products and services. So this again kind of is looking at this before in regards to crypto, where you had like um, a decentralized ID, and the speaker there was kind of saying that the decentralized ID, where you might have more network effects with a decentralized ID than the kind of current um, centralized IDs. And again, from asking questions regards to that, it's not like even these companies use the centralized ID that well at the moment anyway because of data issues. There's all sorts of loss of kind of data quality regards to kind of recommendation engines. It's a funny area because it's these kind of tech companies are kind of built off these data silos and data lakes. They seem so sophisticated, and they are very sophisticated. But there is also a lot of like data lost in the system. So again, that presumably does present opportunities for other or more specialized kind of data companies to supply, prevent, I said, better recommendation systems and things like that. Um, so yeah, so this trend is ultimately may evolve recommendation systems into a unified digital ecosystem where which relies on responsible computing mechanisms that yeah, again links numerous individuals and in various channels. So this is again there might be the ability for companies, especially smaller companies, who don't have the access to again these sorts of th category specific kind of recommendations. Uh, they like a company might be only able to make recommendations for a kind of category that they have enough data for, and like you have to be of a certain size to get that data, and then the data is only about certain customers. So again, there's lots of like gaps there, where it's like smaller companies wouldn't have access to this data. So they're immediately at a disadvantage in regards to product recommendations anyway. Um, two bigger companies, so they need to be joining these. again platforms, but the platforms recommend for their own kind of interest as opposed to the kind of smaller companies' interests in a way. So the ability to kind of is to kind of move from a product to an ecosystem where and or things kind of more these kind of context kind of aware recommendation systems can create kind of more individualized not recommendations but kind of profiles could perhaps be used to allow a more unified digital ecosystem. Again, this is the decentralized ID that could create bigger network effects than the current systems uh, are creating. Yeah, so usability to responsibility. So, as I said, AI generated content should be more verified and moderated, and proper watermarking techniques are necessary. Yeah, so there would be more ability to regulate, I suppose. I said I said more kind of current techniques. The ability of kind of more less specialized models allows for um, perhaps safer methods than are available today. Okay, cool. So that's a brief overview of the trends in regards to multi-agent systems.